Hello everyone, welcome to Engineering Scale Models. I am Jason, your host, and I do models. I hope everyone is doing well on this Sunday. I am going to stream some more testing on the Switch that I streamed a bit of yesterday. So let me just find something here. So, just want to do something here. Okay, so I can hide that. So, I got this document from the coder, his YouTube channel, fantastic repair work. He's taught me a lot. And I went ahead, it's 20 some odd pages. I went ahead and printed it out because looking at the computer and then trying to jump from page to page excuse me, was getting a little bit difficult. I did most of this stuff was already done, but there's some about docking and EMI filters, but that's not what I'm interested in because of where I left off yesterday. I know there's power to the power pin, power button. I know the power button's good, so I want to see there is a printouts here of the pinouts for different clusters on the board, and I have them all here. Some of these got messed up in the... Is this still supposed to be printed on A4 paper? I don't know. So if you go through all the way through cluster A and cluster L, then it has the SD card reader if you need to reroute the pins. But here is the part that goes with these clusters. And here is one sheet for the front, or for the back. Ink's going to be wet for a while. And here is the other one. So this is the one for the back of the board. So what I want to do is I want to check that, and then I want to come in here and I want to check for some voltages on different things. It's an incredible document. If you go to the coders page, community page, he has it available for people. And then there's this section here, but then there's this section down here that has diode readings for the maximum ICs. This is the maximum IC by, I'm assuming it's by NAND. Yeah, so we're going to find these two maximum ICs, and we are going to check that. So I'm going to put that there like so. I'm going to take this section out, put that there, put that there. If I get it out of order, I get it out of order. I should have printed it on regular paper. So I got this here. I will pull the document up on the screen, but I wanted to see this for reference purposes. So if we go to the microscope, before I do anything, if you guys are not in here, I made a couple of new items yesterday, and I made one about a week ago, and I keep forgetting to talk about it. So, as I haven't used it yet, but I've used it. I haven't used it on a video or a stream yet. So this is the first thing I made. I made this little tripod thing that has a test probe on there, so I can accurately probe my board. Move that out of the way, so I can accurately come in here and touch a certain point on the board. You know, I can loosen it and tighten it. It's just temporary, because what I have now is I have a probe zip tied to one of my gooseneck lights, and it actually stops me from having a certain amount of light. But so I'm gonna try it. This worked the other day to probe different things here. Let's do this and then this. Like I can come in here Where is the chip I'm looking? So I can come in here and I can touch different points on the board. It's a little shaky, but what I'm hoping to do is to come in here with this probe and do the same thing here. And do the same thing here. So anyways, that's my goal. I'm testing it out. So I'll probably make more revisions, jab it into my finger. So I'll probably make more revisions on that. But another thing that I have that I came up with is if you come over here to I did a review on this New Concepts bench pen. This is for jewelry making. It's a clamp that clamps to your device, and you can slide a plate on it, and you can cut plastic, metal, brass. It's great for scale models, but I adapted it. I put a rubber mat down, and I made some board holders. So I can take the Nintendo Switch board here. We'll leave the power on. We'll take the power off just so. So I can take the Nintendo Switch board and I can put it here. Say I need to change the USB port. So I can hang the port over there. I can lock the board down like so. I got the port hung over and I got the board clamped in there, and then I can bring my scope forward. I can bring the scope forward. And I can work on the port of the Nintendo Switch. So, and I can even square it up. So, say I need to work on the port of the Nintendo Switch, I have access to it, and I can even go out a little higher if I go up a little bit. I can go out a little higher if I go up a little bit, and then I can actually go down really far, and I can get really close into those pins and be able to test them and whatnot. So, I made that about a week ago probably. It's a pretty neat little concept. It's very helpful. Let me put this back in here. Now, what I want to do is, in the future, I want to get this off of here. Let me see how I can explain this. This device right here has these dovetail joints on it, and it basically just drops on there. Well, New Concepts, they make a adjustable dovetail clip that clips on here, and you can move it up and down and then clip this plate on. So I want to get the large one so I can actually move this up and down and get my scope in there at different heights and be able to use different angles and heights and stuff. This is a little low for me. I have to actually lower my chair if I'm going to do any work on it. So the adjustable height clip that goes on there is going to be very helpful. These are not cheap. I'm going to tell you that right now. It serves its purpose for what I use it for. And then the fact that I can now use it for doing the electronic stuff, it serves even yet another purpose. But they're not cheap units. They're also very hard to find. So, and the accessories are very hard to find. But they make tons of accessories that fit on these ones. You can even get them with a striking surface. This has got the magnetic surface. The striking surface cost about $100 more. So I was like, no, that's okay. I'll use my own anvil. So I got the magnetic surface because it was cheaper. So that is that. Let me see if I can get this straight. Okay, so Let me put this board back in here. Oh, actually, I'm going to flip the board over because I want to check these clusters here and see what kind of readings I get. So I'm going to start in this area up here with cluster A, and I want to see what it says I should be getting and what I actually get. So I'm going to put that into there. So I'm going to hope I can put it in there. Alright, so that's locked in there. Let's go over to here, because this is where we're looking. Actually, what I'm going to do is I'm going to get rid of this piece of tile. So I'm going to put my vise down there. It's going to be a little harder to move on the mat, but if I look here at the top point, test point 1 is right there, is test point 1. So I'm going to actually try this thing right here and see if I can use it. So I am going to clip my red probe on ground because I believe I want a, what does it say? Okay, pad 1 is battery ground. Okay. Oh, a lot of this stuff is, oh, okay. Oh, well, never mind. We're gonna, a lot of these stuff are pulse stuff, square wave output, so that needs to actually have a working switch to check these. I thought they were diode readings at first, so let me go back down here to the next thing I wanted to check is the diode readings of these Maxim chips. So let's take a look at these here. So here are the diode readings here. If I put them right there and I move the microscope camera, where is the mic? If I move this over here, there, you guys can see that, and it's got a little bit of a light glare on it. Just turn that and turn that one. Okay, you can see the readings that are on the paper that I'm going to be checking. So let's locate this on the board. So it's not the main Maxim IC. I believe it's this one right here by the NAND. I believe that's power for the NAND. So let's check that PMIC real quick. Wrong way. Okay, so now we can do, these are diode mode readings, so we can do red probe on ground and software. Meter software would be super handy right now. So nobody has joined chat. That is interesting. And let's put it on diode mode. And we will turn off the beep because I don't need the beep. So we're going to check this here. We're going to put this underneath the scope. Where is it at? There is the Maxim IC. I need to orientate it the same way as the picture. I'm not going to be able to test it if I do that. So it's upside down, which is okay, I guess. So we should have, and then let's clip this to ground. That would be useful. And clip my black probe to the probing unit. And let's get in here and test a capacitor. Let's check. This one right here should be 3.97. So I'm going to have to turn this again. to get in there. 3.97, so it's this one right here. And it is indeed 3.81. Okay, so the next, oh, that was the one I checked. That was the one, so it's this one I gotta check. And that one is 4, so 4, and then that one was right. So then we have 3.80 on this cap here. And yep, that's right. And then we should have 0.085 on this side of yep, that's about right. And then if we come this way here, we should have, just crisp that up a little bit. So on this side of this cap, we have 0.097, we should have 0.086. That's fine. And then we have the inside cap here. Assuming it's this one first. This should be 380, yep, and then this one should be 380 also. So 374, that's fine. And then we have, this one is should be 0.093. 0.093. This one should be 0.806. 0.9, yeah, that's close enough. And then we have 0.093 and 0.092 on these two. So we have 0.096 and 0.096. So that one seems to be okie dokie. So let's check this one down here, and I believe that is this set of this PMIC, this max IC here. So let's check this one here. Alright, so let's see here. So this lonely cap on the outside should be, that should be 0.17, 2, that's fine. This should also read that, yep, should be the same, yep. And this, about the same as the other one. It's about the same as the other one. That is the same. All that's the same. This should be 0.380. Yep. And then 399. Oh, wait a minute. Yep, I need these two caps in. The middle should be 380, 378. Okay, so both those ICs are good. So now what I don't have is a reading for the max IC on the back. So I was hoping, well, I wasn't hoping that was an issue because they're BGA chips, and I didn't want to mess around with BGA chips. So let's put this in the back and let's find my present voltage paper. So present voltage. caps. A lot of components. Okay, so this one is supposed to let me know where voltages are present. But it doesn't say if they're present when it's powered on or before powering on. So I'm not sure. Well, it says a 4 volt permanent here, so I would say that with the battery connected I should have 4 volts on that cap. So we're going to check that right now. So we're going to put this there and we're going to check to see if we have 4 volts on this cap on the max IC. So I'm going to put it like this again. And I'm going to this time hook up the red probe on red. I'll use the other unit this time to see if it's any better for comparison. Then we'll do the black on ground. Black on ground. Now I need to connect this battery and also be able to see what I'm doing. Okay, so this is where I need to measure. Let's see if we can find it here. So if I turn it to the way I have the board oriented, which I can't, I need to go this way with it. So let's put the light here. Let's get this max IC into shot. So let's turn this back around. So I should have on this test point here, on that test point right there, I should have 4 volts. So with the battery connected, in theory. Okay, so I'm going to put my meter on DC voltage. So DC voltage, not current. And that changed it. So let's connect this battery up here. Alright, the battery is connected. And let's see if I have 4 volts on. And I do have 4 volts on that line. Okay, so there is voltage going to the max IC. So, now we are getting somewhere here. So I have 4 volts on the max IC. That leaves us with, is there an issue after the max IC? This is quite strange. This is quite strange. Oh, I was half expecting not to find voltage there, so let me move this out of the way for a minute. And let me just try something here. So let me take this right here. Take that insulation thing I had on there off. And let me go with this case right here, because I know that this is a working unit, or at least the screen assembly and battery are good to go. So let's just see what we have here. So let me plug in the screen assembly. Okay, there's that. Let me get the backlight cable out of the way here. Speaker wire. Okay, so I can never manage to get this in there when I connect the screen first. There it goes. Alright, let me get this backlight cable out again. Okay, so, and the power cable. Okay, so I'm going to put one screw in it just to hold it down for my sake. Screwing it. Alright, then I'm going to connect this up here, like so. Connect the backlight up. And connect the battery up. I know that this battery has been charged up. So let's see here if it turns on. Okay, let's check with the charger. Did we get a charger icon? No, we are drawing 292 milliamps. The battery is fully charged. So let's just try this here. I'm still not getting anything. Oh. And I know this is a good screen. This is my known good screen. don't have backlight. No, I don't have backlight. So if I put the charger this way, what does it do? Yep, 261 and no sun. So there's definitely an issue still. So let's disconnect this battery, because this is for sure a known good board and whatnot. So that is definitely a known good screen and everything. Actually, the only thing that was bad on this was trace on P13, so that is a shame. So let's get this out of there. So there was no backlight, so that is problematic, to say the least. Alright, let me put this in here, put that away. Okay, so what could the issue be? I am running out of ideas. The battery charges. I am getting voltage where voltage needs to get, but when I press the power button, I'm not getting the voltage on the M92 chip. I could very well change M92 yet again, but I really don't think that's the issue because it is charging. So my next option is these diode arrays here. I've seen some issues with these diode arrays, and I was told that they can have issues with things. So I am going to remove them on the next stream. I'm not going to remove them right now because I don't have it set up yet. So I have those parts on order. I have this diode array on order right here. I have that on order. So I am going to order, I have them on order. They should be here 10 to 15 days. But I'm just going to pull them off because I've seen the board work without them. And the newer revisions do not use those. And I know that they can take a hit. It's a weird component. I looked at it on another video. They measure like diodes, and normal diodes would measure. So I'm not sure if they're bad, but I'm going to pull them off. There's also one on the back here. I have to confirm that that's the one, but I think it is. So I'm going to pull those off and see if I get any more luck of this working. So yeah, that's where I'm at on this now. So I didn't want to do much today. It's a Sunday for us, and I gotta get ready. Tomorrow is my birthday, so I'm not sure what I'll be doing. Probably not much. So thank you guys for watching. If you're watching this on repeat after it's been not live anymore, thank you so much, and I hope everyone has a